Hello, and welcome to today's ACM Tech Talk. This webcast is a part of ACM commitment to lifelong learning and professional development, serving a global membership of nearly 100,000 computing professionals and students. I am Elisabetta Di Nitto, professor at the Politecnico di Milano and vice chair of ACM SIGSOFT and a member of ACM. My research interests and expertise lie in the area of software engineering, and in particular large-scale open service-oriented systems with a special attention to the techniques to make these systems self-adaptable to changes in the environment and in the performance of their distributed components. So you can learn more about my background on the bio window on your screen. So for those of you who might be unfamiliar with ACM or what it has offered, here is more information. So ACM offers educational and professional development resources that bolster skills and enhance career opportunities. Our members can stay competitive in the constantly changing world of computing with a range of ACM Learning Centers resources at learning.acm.org. And you can see some of the highlights on your screen. ACM recognizes the role of computing in driving the innovation that sustain the competitiveness of in a global environment. In particular, ACM provides a timely computing information published by ACM, including Communication of the ACM and Q magazines. Access to the ACM Digital Library, that is the world's most comprehensive database of computing literature. International conferences that draw leading experts on a broad spectrum of conferences topics, computing topics. And support for educational research, including curriculum development, teacher training, and the ACM tuning and ACM prizes in computing awards. And the update ACM Code of Ethics, that is a collection of principles and guidelines designed to help computing professionals make ethically responsible decisions in professional practice. ACM enables its members to solve critical problems using a new technology that enriches our lives and advances our society in the digital age. So before we get started, I would like to quickly mention a few housekeeping items shown in the slide in front of you. First, the slides will advance automatically through the event. On the bottom panel, you will find some additional widgets and resources. If you are experiencing problems with the slides or audio, press the F5 key in Windows or Command+R on if you are on a Mac, or refresh your browser on a mobile device. Or you can close and relaunch the presentation. To control volume, adjust the master volume on your computer. If you have questions during this talk, please type them into the Q&A box at any time and click the submit button. I will organize the questions as Lorin speaks, and he will reserve time at the end of the presentation to address them. This session is being recorded and will be archived. You will receive an automatic email notification when it becomes available. And check learning.acm.org for updates on these and other upcoming webcasts. At the end of the presentation, you will see a survey open on your screen. Please take a minute to fill it out to help us improve our tech talks. You may also open the link to the survey at any time from the resources window on your screen. You can use the Facebook and Twitter widgets on the bottom panel to share the presentation link with your friends, as well as tweet comments and questions using the hashtag ACM Learning. We will be watching for your tweets. We also have a community discourse page to continue the discussion after this webcast, including questions we won't be able to get through during the Q&A session. So today's presentation is titled Ops, Learning from Surprise at Netflix, and this is given by Lorin Hochstein. So Lorin Hochstein He's a senior software researcher at the core cloud operations and reliability engineering team at Netflix, where he works on ensuring that Netflix remains available. So a big effort. He was previously senior software engineer at SandCreek Labs, lead architect for cloud and services at Nimbus Services, computer scientist at the University of Southern California's Information Sciences Institute, and assistant professor in the Department of Computer Science and Engineering at the University of Nebraska-Lincoln. He is also an ICM member. So, Lorin, without further ado, please take it away.
Thank you, Elisabetta. All right, so let's talk about outages. So at Netflix, we use the term incidents, which is a little bit more general. So that includes outages, any sort of major service interruption, right? So when one person can't stream video at Netflix, it's a customer service issue. When many users are not able to watch Netflix, that's an incident. So incidents are scary things for organizations, right? We don't like them when they happen. And there's a couple of aspects to that. One of them is that, when an incident happens, the system has done something we didn't think it would do, right? It behaved in some surprising or unexpected way. And what's worse, not only did it do that, but something bad happened, right? There is some negative impact to the business, right? There was some sort of outage, service interruption. People aren't able to use it. They're not able to do transactions. It hurts us, right? We don't like that. And it creates uncertainty in the organization, right? We thought the system was reliable and it wasn't. And that makes people nervous. They really are uncomfortable when an incident happens. And what happens is they want to feel that everything is okay, right? So when an incident happens, it creates this event of uncertainty, and people want closure. They want to feel as if that has been effectively dealt with. And in particular, what people want is that they want to build confidence so that they can believe that this is not going to happen again, right? And so the question is, well, what do we do so that we can feel better that this kind of bad thing that happened is not going to hurt us again? And so what do we do in our industry? Well, most companies do what we call at Netflix an incident review. And at other companies, it's often referred to as a postmortem. I'm not particularly enamored of the term postmortem because in our field, here at Netflix, nobody dies when an incident happens. So we call it incident review or an IR. And I'm sure, anyone watching, if you're at a company that operates some kind of service, I imagine you have some sort of post-incident process as well. And so what do we do in those processes after an incident, right? Well, one thing we do is we try to figure out what happened, right? Well, why did this happen? Why did the system break, misbehave in this strange, unexpected way, right? And so what do we do? Sorry, my slides are going the wrong way. There we go. All right. So typically people do what's called a root cause analysis, right? Find the reason why it broke, right? What was the bug? What was the configuration error? What was the wrong button someone clicked, right? So that we understand why the system did what it did. And then, once we understand why, what typically happens is we generate a set of action items, right? We try to answer the question, what is it that we can do to make sure that this bad thing that happened never happens again? Right. And so we generate those list of action items that we think will prevent it from happening. And we, ideally do some follow up to make sure those things actually get prioritized and done. And then once all that happens, then people feel better, right? They feel like they've gotten closure. They understand what happened. They see that they've gotten some evidence that this kind of problem is not going to happen again because of the action items. And then the organization can get past that and feel safe again. Until what happens? Another incident happens later on, right? And the difference with the next one is that it looks completely different than the last one, right? Like if we did the action items right, then the new one is different, but it's a completely different thing. And then the cycle repeats. And so the claim that I want to make in this talk is that we as sort of technical organizations, we can get more out of incidents. We can learn more from incidents than just how to prevent that particular incident from happening again, right? So more than just preventing the last incident from recurring. And I really like the way that John Allspaw puts it. So John Allspaw is the former CTO of Etsy. He now runs a consultancy company called Adaptive Capacity Labs, which works with companies on doing sort of better incident reviews. And what he describes incidents as is unplanned investments, right? When an incident happens, your organization has already spent money, right? Because there was some business impact. They didn't want to, they hadn't planned on it, but it has happened. And so the question is, how do you best leverage that money that you have already spent, that investment? What can you do about that? Another claim I want to make today is that what you can learn from an incident is not a direct function as to how bad that incident was, how severe it was. Now, certainly the attention that an incident gets within an organization is always going to be a function of the severity, right? Like your organization is going to put a lot more attention on, the big business impacting things that put you in the media, right? But it's not necessarily the case that you can get the most out of those. And if you leave that, if you take away that learning is not proportional to impact, then one of the consequences of that is that we can actually learn just as much from an incident where there's no business impact at all as we can from an incident which was very, very severe. Now, in this case, it's not really, I put like incidents here in scare quotes, because if there's no business impact, that's not really what we would call an incident. And we don't call that an incident in Netflix either. So we need another term for that sort of thing. And the term that I really like to use is operational surprise, because I think that really captures well the phenomena. So an operational surprise is anything that happens in your production environment, but it could even happen in your test environment, that you didn't expect. Right? The system did something that you did not think it was going to do. That's surprise. Right? Your mental model does not match the world in some way. And so at Netflix, we call these operational surprises oopsies. And an individual operational surprise is called an oops. And what we encourage people to do is to self-report the oops, to tell us about when they encounter an operational surprise in their part of the Netflix ecosystem. And we literally call these individual surprises oopsies. Individual ones are called individual one is called an oops. There's a Jira project inside of Netflix, and it's called oops. And so here's an example from oops. This is oops 170. And it's titled New Spinnaker Resilience Feature Caused Too Much Pressure on Titus. So Spinnaker is a Netflix system that is our continuous deployment system. So you use Spinnaker to deploy new software inside of Netflix. Titus is our container management system. So both Spinnaker and Titus are open source. You can find them on GitHub. I'm going to be drawing all of my examples today of oopsies at Netflix from Spinnaker for two reasons. One, because Spinnaker is an open source project, it's easier for me to talk about, all the code. You can see all the pull requests and things like that on GitHub, and I'll even have some screenshots. And also, the Spinnaker team happens to be particularly good at self-reporting oopsies. So they sort of give us like a rich set of data to work with. So they're a great team to work with inside here. All right, so one thing I'll say, actually, let me just go back a second. I really like this kind of operational surprise where there's some subsystem that has been built that's designed to improve reliability that ends up contributing to a problem, right? And we see this over and over again, that you've built something that was designed to make the system more robust, but it interacts in some unexpected way, and that causes a problem later on. And so you can see, if you look at this is a screenshot from GitHub, there's a pull request to add some back-off configuration so this one service doesn't end up hammering Titus, which is what happened here, right? So it doesn't hit it quite as hard. So here's another example of a change you can see in Spinnaker that is related to an oops, an operational surprise that happened inside. And you can see here that there's a bump in a library. So Redis is a Redis library, client library. So if you're not familiar with Redis, it's a data store. You can think of it sort of like a database. And so Redis is a Java library that talks to Redis. And here they bumped the version of this library, I think from 3.90 to 3.93. And if you look upstream at what happened between those two versions, you can see there was a bug, in 2.91. They bumped this version to fix the bug. And then they bumped this version to fix the bug. And then they bumped this version to fix the bug. And then they bumped this version to fix the bug. And then they bumped this version to fix the bug. And then they bumped this version to fix the bug. And then they bumped this version to fix the bug. And then they bumped this version to fix the bug. And then they bumped this version to fix the bug. And then they bumped this version to fix the bug. And then they bumped this version to fix the bug. And then they bumped this version to fix the bug. And then they bumped this version to fix the bug. And then they bumped this version to fix the bug. And then they bumped this version to fix the bug. And then they bumped this version to fix the bug. And then they bumped this version to fix the bug. And then they bumped this version to fix the bug. And then they bumped this version to fix the bug. And then they bumped this version to fix the bug. And then they bumped this version to fix the bug. And then they bumped this version to fix the bug. And then they bumped this version to fix the bug. And then they bump in the upstream library. And the bug was there was a connection pool leak, right? So Redis, this library uses connection pooling. And then when you run out of connections, you can no longer talk to the Redis library anymore. And then the service is stuck and you've got a problem. So you can sort of see, if you were to look through the history of the version control of this software, you can see sort of breadcrumbs, hints of operational surprises that we've encountered and how we've dealt with them in the code. Another operational surprise was written up sort of on Twitter by a colleague of mine on the Spinnaker team, Daniel Renaud. This is an interesting case where they accidentally pinned some clusters too high, right? So Netflix is implemented as a set of microservices. We just call them services. So there's a whole bunch of different separate software services inside of Netflix. Each of those services is implemented as like a cluster, a collection of servers, of virtual machines that are all the same. And those clusters sort of get bigger and smaller. And here they had accidentally made some of the clusters too large, right? They had too many servers in them. Now, there's no operational impact to the customers. It just means the servers were running cold, but we're using resources we don't really need to use. And if you want to read the story of what happened, there's a link on Twitter here. Daniel Renaud goes into some detail about how that happened. And you can see, if you look at the pull request history for this project, there's they reverted a change here. And you can see one of the comments is, what does it say? Turns out it's caused a couple problems internally, right? So that comment is a reference to this surprise that they had encountered, where they'd accidentally pinned a whole bunch of clusters too large. All right, so for the remainder of this talk, I'm going to split it up into 3 different parts. For the first part, I'm going to talk about our goals in asking people to report operational surprises, what we hope to learn from collecting information about oopsies. For the second part of the talk, I'm going to talk about the kinds of questions that we ask. So after an operational surprise happens, one of the main ways we collect information is to ask people questions. And so what kinds of questions we ask. And then the third part of this talk, I'm going to talk about how we actually capture what we've learned into a document and share that document out with the rest of the organization. So let's start with what are the kinds of things we hope to learn. And if you listen to, there's sort of a movement now about like learning from incidents in software. There's a lot of discussion about learning. And what I want to try to do here is get a little bit more concrete about the kinds of things we try to learn when we examine operational surprises. And I really like, so at a very high level, I really like this quote that's been attributed to Otto von Bismarck that says, "Fools learn from experience. I prefer to learn from the experience of others." And that's really our goal. We're trying to, as an organization, learn from the experiences of individuals inside the organization, right? We know that people get better with experience, right? I mean, that's why senior engineers command higher salaries than juniors, because they have more experience. And if you sort of touch the stove and you get burned, not to touch the stove again. And the challenge is, how do you teach other people not to touch the stove without each of them having to individually touch it? And that's what we're trying to get at here. How can we transfer those experiences to other people? So one of the main things we're trying to get out of looking at operational surprises is to identify gaps that exist inside of the organization. And there are different kinds of gaps. So the first gap I'm going to talk about is what I call a tooling gap. And looking at tooling gaps, I think, is one of the places where our industry, I think, is actually pretty good when they do their post-incident review. And a tooling gap means there's any sort of problem with an operational tool that makes it sort of more dangerous. So, for example, the tool doesn't convey the information that an operator needs to understand what's going on, or it's too easy to sort of to do something that's unsafe. Those sorts of issues around sort of human-computer interaction are the kinds of things we're looking at. And operational surprises are sort of a rich set of data around people having trouble interacting with tools. And this is the case I'm going to go into the most detail. So I'm going to talk about a change that was made to the Spinnaker user interface after an operational surprise happened. So this is a screenshot of one of the Spinnaker screens. Here we're looking at information about a particular, what's called a server group or an auto-scaling group. So this is just a group of virtual machines that all are running the same software. And this one's called example 405, V405. And so you can basically control the size of one of these server groups. And here you can see the min size is set to 12, the max is set to 5,000, and the desired is set to 49. Right? And you can edit the min and the max. You can resize those, but the UI does not let you change desired. And you can see there's this like yellow text underneath. Now, the fact that you can't change desired and that there's this yellow text that explains what to do to resize, that was not always part of the Spinnaker user interface. That was added later on. And I'm going to tell you the story of the motivation for why those changes were made, why the desired is no longer editable, and why there's some guidance as to how to resize a server group manually. So consider, so as I said, at Netflix, we are organized into services. Each service runs as a server group or a cluster, a collection of virtual machine instances that are all running the same software. So each of these green boxes, think of it as a server or virtual machine. And that size is configurable, right? So we run inside of the Amazon cloud. And so EC2 is the service that lets us run servers. And when you have a server group in EC2, you can set the desired size. You can say, I want 128 servers, and then it'll launch 128. And if I change this to 130, then EC2 will boot up 2 more servers. If I change it to 100, it'll terminate 28 servers. We can use that to control the size. Now, one thing to know about Netflix is that the load on our service, the demand we see, varies throughout the day, right? And if you think about it, it makes sense because if you notice your own TV viewing habits, if you watch television, you probably watch more TV in the evening than you would like in the morning or the middle of the day. And so you actually see this sort of waveform pattern. So this is a graph of what's called SPS, which is stream starts per second. This is a count of the number of times each second a Netflix user presses play and starts successfully being able to stream video. So because the load on our system varies over time, we actually vary the number of servers we have running over time. We grow and shrink these server groups, these clusters over time to match the load that we expect, that we're seeing. And Amazon has this service called the autoscaler, which will automatically adjust the size of your server group for you. And so the way it works is it takes some metrics from the servers. So for example, you might look at CPU utilization, or you might look at the number of requests that are coming in to the servers, the average request rate. And based on that load, if that load is going up, the autoscaler can increase the server group size to compensate, or to cool down the servers, or if the load's going down, it can shrink the server group, right? And so you give it like a floor and a ceiling, right? You give it a min. You never want it to go below 20, and I never want it to go above 1,000. Otherwise, the autoscaler controls the desired, how many there should be, and then EC2 figures out, given how many there are and what the desired is, whether it should terminate or launch new servers, new virtual machine instances. So one day there was a team that owned a service, and they started getting alerts that the disks were filling up. They were getting, I think, like 80% disk utilization. Alerts were firing. So it wasn't like an emergency, like the service was failing right now, but like there was a problem. And what they decided to do as a short-term measure is to launch new servers that had basically fresh disks, and so that would buy them some time while they were trying to figure out what was it that was causing the disks to fill up. And so at that point in time, in Spinnaker, you could set the min, max, or desired. These are all editable fields that you could set on a server group to control the size of it. And so what one of the engineers on the service team did is they scaled up the desired size. They changed desired, say, from 128 to 256. And so this is what happens, right? So they change the desired to 256, and there's 128 servers in the server group. And so what EC2 says is, hey, your server group has 128 servers. The desired is 256. I need to launch 128 new servers. Now, I've colored the new ones in gray, and that's a convention that Spinnaker uses in its UI. And that tells you the servers are started up, but they're not ready to take traffic yet because there's some startup process that's involved, right? First, the virtual machine has to boot, and then the Java application has to start up, and then eventually it passes its health check and it's ready to take traffic, right? But there's some lag time between when you start an instance and when it actually turns green and is ready to take traffic. So this process kicks off. And then what happens next is the autoscaler, which is the thing that automatically controls the size of the desired based on the load, says, hey, the load, based on your current load, you only need 128 servers. And so it changes the desired back from 256 to 128. So now there's 256 servers in the server group, but there's only 128 that are required. And so EC2 says, hey, there's 256 servers in this group, but your desired is 128. So I need to terminate 128 servers. Now, EC2 does not know when a server is ready for traffic from Netflix's perspective. It doesn't have access to our health check information. So what it did is it terminated the older 128 instances, which were all the ones that were ready to which were healthy and could take traffic, and the new ones, which were not ready to take traffic yet, were the only ones that were left. Now, from the user's perspective, the service owner had changed the desired, and what they saw was that the server group went from green in the UI to gray in the UI. So they didn't see it double and halve again. That happened too quickly. And so what they thought is, hey, somehow my server group got disabled, because gray also means that an instance is not enabled. And so they tried to re-enable it, but that didn't do anything. The server group was enabled. It just, these were still in the process of coming up. And this one was actually not even an operational surprise. This was an incident because this was a service that no longer was able to take traffic. And then until these came up, there was a little bit of a service interruption, and there was some customer impact. And so, as a consequence of that, the conclusion was that it's actually dangerous to allow users to set the desired field when autoscaling is enabled. And so, what the Spinnaker team did is they just disabled that. If your server group has autoscaling enabled, you're not able to set desired on that field. Now, in addition to tooling gaps, there are also operational expertise gaps, right? There's a very wide range of operational expertise inside any organization like Netflix. And in the case I just talked about before, not only was there a tooling gap, but there was a gap in the understanding of how the autoscaling system worked, right? And this team, the reason they set desired was that that's what they always did for resizing their clusters, and that had always worked in the past, right? And so if something always works, you keep doing it. And so that highlighted that there was a problem in people's mental model of the behavior of this control system that we were dependent on. And if one person has a problem understanding the system, there's probably other people in your organization that don't understand it either. And so it's good to highlight those things when you encounter them in operational surprises. We also look for resource gaps. And here by resource gaps, I mean human resources. I mean teams that are running too lean, that are too close to the margin, that have too much work to do based on the size of the team. And there's two reasons I personally worry about resource gaps in any organization. One of them is this thing called the law of stretch systems. And the law of stretch systems is this phenomenon that you see everywhere, where every system, and by system here I mean socio-technical system, like it includes the people and the technology. In any socio-technical system, it will eventually be pushed to its capacity. Right, and if you think about an individual team, let's say you know a team and they're running at capacity, and so they get some additional headcount from the organization. So initially, when they hire someone new, they'll have some slack. But what will happen is that they will be asked to do more and more work until they're running at capacity again. And this happens everywhere, right? So you have to sort of actively fight against running at capacity because all the incentives drive you in that direction. The other challenge with resource gaps is this thing called the law of fluency. And what the law of fluency says is that if you're dealing with someone who is skilled and you start to overload them, you're not going to get an early signal that they're overloaded because it seems like they can handle the work. So this is the phenomenon where, like, if you want something done, give it to a busy person. Like if someone is skilled, they are actually able to handle some overload. And if you ask them if they're okay, they'll say, yeah, I'm fine, I can handle it. But really they are starting to degrade, and you're not going to be able to see that degradation until they're absolutely overloaded. And you will see this happen in operational surprises when you have people who are involved in an operational surprise who are cognitively overloaded, right? You imagine someone is having to task switch between different things. If there's like an overly complex deployment process, or they're managing too many services, you can see evidence of that in the operational surprise. So you might say, oh, they made a mistake. But if you look and see, well, they made a mistake, one of the contributors was they were just trying to do too much, and that person has too many responsibilities, right? And so you can see signals of that looking at operational surprises. You can also use operational surprises to get a better understanding of how your system works. Everyone inside an organization only has a partial view of how the overall system works. And every time a surprise happens, we learn something we didn't know before, because by definition, the system did something we didn't know that it did. And so as an example, from one of the write-ups that we've seen, there's a line, it came as a surprise that X calls Y's endpoint. Like the engineers didn't know that one service was talking to another service. And so that's useful information to capture and to teach other people. The last one I'll talk about which is most interesting to me, is this idea of facilitating skill transfer. How do you learn from the experts inside of your organization? And in general, the best way to learn from experts is to watch them in action, right? I mean, ideally, you're on the same team as them and you're working alongside them, and you see what they do. You see how they interpret signals, which tools they use. You ask them how they make their decisions. And the best way is actually watching them solve real problems. And if you document how experts mitigated operational surprises, then you are able to capture in the moment how an expert is solving a real problem. And that is very, very powerful. All right, so let's switch gears now and talk about, the operational surprise has happened. Now you want to know what kinds of questions do you ask people who are involved so you can learn as much as possible from what happened. And so what I would encourage you to do is when you have an opportunity to do some kind of investigation. You can't investigate all of your surprises. You have to sort of develop an intuition about which ones are going to be the most sort of the meatiest ones based on how much time you have as well. But you really want to, if you can, spend the time asking these questions and doing an investigation. The challenge is you don't want to call it an investigation because you don't want it to be sort of like a big formal thing. People, there's a stigma around the term investigation. It sounds like a criminal investigation. You're not investigating the people who were involved. You're investigating the overall system function. For example, we interview people, but we don't call those interviews. We call them chats, right? Because we don't want people to feel that they're being interviewed or investigated. So you really want to keep it, informal with your interactions so people feel comfortable talking to you. The top level question we are always trying to get at, we're always trying to answer in all of our oopsies is how did we get here? What were the series of events that led us to this place where the operational surprise happened? And in fact, our write-ups are all called, the title of the write-up template is How We Got Here. In particular, it's really tempting to try to, say, when an incident happens, you shouldn't have done that, right? Like you should have tested that first, or, you should have had someone review that. You shouldn't have been so quick at that. But what the question you really always want to ask is, for any time an operational surprise happens, there's different actions that people took, right? People make code changes, they make config changes, they interact with operational tooling. And they made decisions. And in hindsight, it might look like those decisions were rash or foolish. But in the moment, those decisions made sense to the person involved, right? Like they had to have made sense. Otherwise, they would not have made those decisions. And so the onus is on you as an investigator is to answer the question, for every action that was a contributor to a surprise, how did that action seem reasonable in the moment to the person involved, right? Because that is the only way you will really understand how that surprise actually happened. The other thing to keep in mind is that in a complex system, an operational surprise is never like one thing that caused it, right? There's always multiple different contributing factors that all had to be true at the same time for the surprise to manifest. And so it's important not to look for a single root cause, but to try to get at as many of the contributors as you can. And so look at sort of not one path back, but sort of multiple branches. And one way to do that is to not just rely on one person to answer your questions. So one of the things that traditionally is done in organizations when they do some sort of like post-incident review is if they do an investigation, one of the people that was involved directly does the investigation, right? Either the person who like made the change that was related, or someone who was on call and had to deal with the incident in the moment is typically the one that's sort of responsible for doing like review. But really, you're only going to get the perspective of that one person if you do that. And you want to get the perspective of all the different people. So in an ideal case, you would have someone who's investigating who is not directly involved, and they talk to multiple people who are involved in the surprise, either in the events leading up to it or when it actually happened to when it got resolved. All right, so now let's talk about how to actually capture this in a document. There's also running meetings. I'm not going to talk about incident review meetings in this particular tech talk, although it is an important topic. I'm going to focus solely on distributing and sharing through writing up a document today. So, we have a template inside of Netflix that we use for incidents and operational surprises. But if you were only to write like one section of that, then the one that I would harp on is to write a narrative description, right? So this is sort of like, think of it almost like a magazine article story of what happened during the incident, right? So the operational surprise, the oops. This is not a set of bullet points. This is not a just like a timeline, although we do build a timeline first to help us write the narrative. But you really want to tell like a narrative, like as a story of what happened. And one of the reasons I like stress this personally so much is that human beings are wired to learn from stories. If you look at, every single, human culture that has been studied on Earth, they all do storytelling, right? And if you go to, a practitioner conference and talk to engineers who do operations work, at line at lunch or like, over drinks, they're just going to tell you, incident stories, right? Like that's how we share our experiences. So if you tell stories, like people will absorb that material in ways they will not through, like timelines and bullet points and PowerPoint presentations. One of the challenges is to figure out like how to target the language, because, you're writing about your, behaviors of internal systems, and typically you need a lot of context to explain like what those systems do and how they interact. And so the guidance that I try to follow and try to give people is imagine the audience for the write-up that you're doing is someone who just recently joined your team, maybe over the past like 2 or 3 months, right? So they're sort of familiar with some of the systems inside the company, but not most of them. They could, it would help them if you sort of explained in more detail. So to err on the side of explaining a little bit more about how these different systems work, to make it more accessible to different people in your org who might not actually know how that part of the system actually functions. So in addition to the narrative description, we have a section called contributing factors. And so these are like pulling out from the narrative all of the things that had to be true for the surprise to happen. Now, these are not, we try not to call these causes. These are not necessarily all bad things, right? Sometimes, don't think of these as like mistakes or bugs or things like that. These are just all the things that had to be true for the surprise to happen, or for it to be worse than it was, or for it to be more severe than it could have been otherwise. And so I'll go through some examples. So these are some examples pulled from Spinnaker related oops write-ups. So here's one. Front 50 provides an inconsistent view of application permissions, and this triggered endless retries. So Front 50 is one of the Spinnaker services that keeps application metadata. So it keeps configuration information about the different applications that Spinnaker manages. And so what happened is there was this other service inside of Netflix that was talking to Front 50. And this other service was a declarative service. So it basically trying to set some application metadata. And what it would do is, it reads the application metadata. It says, oh, it says, this field says foo, I want it to be set to bar. And it would say, write it as bar. And Front 50 would say, okay, I've written it. And then it would read it back and it would still be foo. So even though like it was the right seemed to succeed, when it read it, it didn't match what it had written. So it kept doing that over and over and over again. It kept like writing, and the write would succeed and it would read and it wouldn't match. And that retried over and over again. And then you had this sort of endless cycle. And so the fact that Front 50 had gotten into this weird, inconsistent state with some of the application metadata was one of the contributors in that case. So that's sort of a very sort of technical kind of contributor example. Here's another example of a contributor. So there was a similar feature that had been deployed that was already in use. So enabling that feature in this case seemed like it was low risk. I really like this contributor because it highlights the distinction between taking a risk and running a risk. So if you take a risk, you're taking an action that you know in advance is risky, right? So if you push code to production that you haven't tested, I would say you're taking a risk. You're doing something that's deliberately risky. When you're running a risk, you take an action which you believe is not risky, but because your mental model of the world is incorrect, it turns out that it is risky. And it's important to highlight that this happens a lot, because what that means is you cannot just tell people to be more careful. Because engineers are not always in a good position to assess how risky their actions are. And that we need reminders about that. Another great one, this was a contributor. So this engineer X was out sick when the feature was deployed. So this operational surprise involved the behavior of a particular service, one of the particular services, and there was one person who was like an expert in that service, and they happened to be out that day, and so it was harder to resolve that issue. And this happens a lot in organizations, and it's sort of a function of the law of stretched systems again, right? Well, what happened is that teams will tend to specialize their knowledge, right? Like I work on system X, and that's where like my knowledge is. You work on like subsystem Y. And that's sort of an efficient way to split up your work. But what happens is you end up with all these different individual single points of failure where you have local experts. And if they're not there when an incident happens, things get much, much worse. We track mitigators, right? These are things that kept the surprise from being worse than it was, right? So you can think of mitigators as if they weren't here, this might have actually become like a full-blown incident. This is a good one. So Spinnaker's staging stack was not impacted, which gave us a backdoor way to monitor and make changes. So many services like Spinnaker deploy first to a staging environment for testing, and then they go to production. So Spinnaker, at one point, like the main production deployment, got into a bad state. They happened to have the staging deployment out. It wasn't designed to be used for recovery, but they were able to improvise and use that existing resource to mitigate the problem. And you see this a lot as well, right? Where engineers in the moment will improvise with existing resources to fix a problem, even if those resources were not designed to solve that problem. And this is one of the flip sides of tech debt, where you'll have some legacy thing that's still out there that you wanted to retire, but you didn't get a chance to do so, that you actually end up using when like the new thing fails in some way and you need to do recovery, you're able to leverage a legacy thing. So tech debt is not all bad all the time. There's the last mitigator example I'll use. There's a team called demand engineering. So there's a team called demand engineering inside of Netflix, and they're responsible for functionality that's called failover. So Netflix runs in 3 different Amazon regions. And if we have a problem in one region, then demand engineering has tooling that can redirect the traffic to the other 2 regions. Now, demand has to scale up all of the clusters in all the other regions so they can handle the new traffic. So they have a set of tooling that allows them to do the sort of batch resizing of clusters that Spinnaker team doesn't have. So when the Spinnaker team ran into trouble where they had accidentally, scaled their servers too large, they're able to leverage demand's expertise and tooling to scale all those different clusters back down to the nominal size. So they're able to leverage, sort of a sister team's tooling and expertise to resolve an issue. All right, so we talk about risks as well. So contributors are sort of like a low-level description of things that were involved in a surprise, and risks is sort of more of like a high-level theme that we see that cuts across multiple surprises and incidents. So here's one. The regression occurred in an area of Spinnaker that is difficult to test. Right, this is a good one, right? So there are parts of your service that are easier to test and parts that are harder. And the parts that are harder are obviously going to be riskier because they're not going to be as well tested because they are harder to test. Misconfigured pools and queues. This is another one, this sort of an operational configuration setting. So by pools, I mean things like resource pools, for example, thread pools or connection pools. And these are dangerous because it's hard to test these sort of operational configuration settings. You can't unit test them. You can't integration end-to-end test doesn't test them. These are things that only cause you problems when the system is under certain types of load. Right, and so they're harder to reason about when they're misconfigured. They're easy to miss. The last thing we have in our template is a section called difficulties in handling. So when the pager goes off, what made it hard to figure out what was going on and to actually remediate to fix the problem. And so one example here from a Spinnaker oops is observability blind spots. So we rely a lot on metrics at Netflix to get observational visibility into how the system is behaving. In this particular case, with the state of the connection pool, and they didn't have metrics around how the Redis behavior was changing. And so, one of the things that's really important for us when we're using metrics to resolve issues is to look to see where something changed, right? We're often just sort of using time correlation and say, hey, we made a change here and this other thing changed at the same time. That might be related to the problem. And they didn't have a metric around that at the time. And then you can see, if you look, here's a screenshot of a pull request from one of the Spinnaker projects where they're adding in those metrics in response to that operational surprise where they found that they were missing that observability. And here's my last difficulty example. They rolled out a particular service called Cloud Driver at 3 o'clock, and then they didn't actually see problems until 2.5 hours later. 5:30, they got paged by an alert. And so we very, very often use time correlation to identify a change that broke something, right? This broke, but we deployed it around the same time, so let's try to roll that back. when there's a big lag between when a change happens and when we see impact, it becomes more difficult to identify what's going on. Then you need a deeper understanding of what the failure mode is. This brings us to the end of the talk here. So if you only remember 3 things about this talk, 3 takeaways, the ones I hope you take. One is anytime there's an operational surprise, anytime the system does something that you didn't think it would do, there's an opportunity there to learn something about your system that you didn't know before. When you're trying to learn about that, you want to ask questions that tell you, how did we get here? How did the system get into this state, and how did we get back into a good state? Because that will teach you like how things actually work in your organization. And finally, you want to tell a good story, because people remember stories and they'll retell those stories. So finally, if you're interested in sort of proceeding in this world, there's some good reading material. There's a document called the Etsy Debrief Facilitation Guide, which has guidance around doing incident retrospective meetings and guidance around what sorts of questions to ask in those sorts of meetings and how to run them. If you're looking for sort of a book-length treaty on this topic, there's the Field Guide to Understanding Human Error by a safety researcher named Sidney Decker. His background is in aviation, but all of the concepts apply in our world as well. And I maintain a bibliography of safety-related papers in this world called resiliencepapers.club, which I encourage you to check out. And with that, I'm going to turn it back over to the moderator.
Thank you, Lorin. So let's move to the questions that we have got so far. I'm going to start from one that came actually before the talk. That is the following one. Please address in the talk any resistance to reporting. For instance, I can imagine that some people either thinking it's a waste of time to report a small incident, or that they don't want to report or publicize a possible mistake on their part. So what is your opinion on this, Lorin?
Yes. So, I mean, we only see, a small fraction of the total operational surprises reported. And it's definitely a challenge for us. And I'll say 2 things about this. One, you want to identify the people who are sort of most likely to report it, to see value, because once people start seeing this, once people see the value in reporting and it being reported, they're more likely to report themselves. So you sort of need to find like the early adopters who are going to be more willing to. Like I have no authority at Netflix. I can't make anyone do anything here. I can ask people, they can say no to me. So I have to sort of find friendly people who think there's value. And then what also happens is when a surprise involves multiple teams, which it almost always does, someone will ask, hey, is there an oops being written up for this? And so it sort of creates a cultural norm inside the organization that we do these when it happens. So I would say, like, as people see value in it and as cultural norm develops over time, then more will do it. But you're always going to see people that either don't see value or don't have time. And the don't have times I personally worry about, because they tend to be over-resourced. And the best I would say is, like, try to just talk to people afterwards, even if they can't get them to write it up, to collect some information from them, because that's probably a signal. If they don't want to report, that's another signal, and you have to collect information in a different way than just getting them to write it up.
Great. So thank you. So we've got many questions. I'm basically lost in the many questions, but one is this one. When there is the same incident happening again, what kind of process are you using, and are you able to correlate this incident that has happened again with the previous incident?
Yeah, so I mean, we do track. We memorialize all of our incidents. So we keep a record every time an incident happens. And so if we see, there's a centralized incident management team at Netflix, which is the team that I'm on. And so that team is directly involved when there's an incident, when it's customer impacting. And so if we see a pattern, if we see, for example, the same failure mode happens over and over again, then that's a signal to that team, that's signal to us to go talk to a particular team to see what's going on there, to follow up with them. Generally speaking, at this point, I would say Netflix's life cycle, we're mature enough that we haven't had to do that very much. The teams have been responsible enough that they've been following up. Sometimes there are long-running things where it takes them a long time to resolve it. And so we see the same incident over time. I saw one that took like, I don't know, like a month and a half, but we knew they were working on it. And so if we know we're working on it, we're happy. And if we don't think they are, then we will individually as a team follow up with the people who we think can do something about it.
So based also on what you just said, so what is the volume of incidents and that you can deal with, and you are able to transform into an incident report and to analyze carefully, etc.? And also there was another question which is also correlated to this, that is, what's the size of the team you belong to that is in charge of handling these situations?
Yeah, so we do different incidents get different levels of attention and write up. So every incident at the like where there's customer impact, there's at least some that's owned by an incident commander, and there's some basic memorialization that gets done on it. For the deeper investigations, we don't do those very often. Like when we investigate, like on my team, there's only a couple of us who do that regularly. There's like 3 of us, 3 or 4, I guess 3.5. And we're doing maybe like 1 a month in terms of investigation. They're kind of long at this point. The operationals, the oopsies are self-reported. So that is a way for us to try to distribute the work across the company, right? So we don't have to, we do some oops investigations, but generally speaking, we try to have people do it themselves so that we don't become a bottleneck in doing it. The team that I'm on is mostly people who do incident commanding, who actually handle the incidents, not do the deep investigations. There's only, and so that larger team is, I forget, 15 now or something. But the people who are more focused on investigation is 3 or 4.
I see. So, and also there are some other correlated questions related to the which tool, if you use a specific tool for handling, let's say, the process of managing these incidents, and if there is a way that if there is a specific approach for you to classify incidents and clustering them in some specific way.
Yeah, so in terms of handling the incidents, we use tools so we have a set of tools that we use in the moment for dealing with incidents. So, we use Slack for communication, we use Jira for keeping track of the status of an incident and then we have a set of a metrics, an alerting system with dashboards so we can, do diagnostic work. In terms of classification, we have some simple classifiers, but what I'm doing one of the things we're trying to do is look across incidents that have happened and try to do some more of a bottom-up classification to sort of bucket them. And that's sort of work in progress right now. I'm hoping to be able to at some point discuss later the clustering that we're seeing right now, but it's still early days in doing meaningful bucketing. And often it's they're very complex. so they can be often hard to categorize. But yeah, I would say that's work in progress. I hope to eventually be able to share more about the kind of categories we see.
Okay. And so another related question is how do you transfer knowledge from the incident report so that also the entire organization can take advantage of this report, etc. So do you just distribute the report and expect people to read it, or there is some proactive approach that you can use to make people know?
Yeah, so we're exploring different channels. So we share out the write-up. We have some meetings internally like an incidents, risks, and learning meeting where we come and discuss certain incidents where we think there are things that like the platform organization can learn in terms of integrating it into tooling. We have an availability newsletter that goes out once a month where we sort of will try to capture some interesting nuggets from some of the incidents and operational surprises and convey them in a way that's a little easier than just reading a whole big report. I have sometimes like posted in like Slack channels, like some interesting things, but we're still like exploring that, right? Like what are good, because that's, I would say the grand challenge in any organization past a certain size is how do you get the knowledge into the heads of the people who need it? And it's a really hard problem. And you can't just blast email out to everybody. You know, like you could spend like 40 hours a week at Netflix just reading documents that other people have generated and still not read everything and not get any of your work done. So that's still something also we're trying to figure out. Like how do we share, what are effective ways of sharing it out to the rest of the org?
Great. And so there are also others, I think, at least a couple of questions that are somehow similar, and the question essentially is, so we have, of course, people who are more on the dev side, others who are more on the ops side, others that are DevOps, etc. So which kind of role is more involved in this incident understanding, investigation, and management in general?
Yeah, so I mean, at Netflix, most of the services are operated by the engineers who write them. So we do, you build it, you run it. So the people writing the oopsies are generally engineers who are doing both development and operations work. The team that I'm on is strictly operations. They just do incident management. So we don't own any software. We don't, and actually we don't even really operate. Like we don't make any changes to production systems. It's up to the service owners to do that. So today, the people who are sort of like the full-time investigators are more on the operations side, but the people who write up the oopsies do both work. They're engineers who are doing both development and operations work.
I see. So I guess maybe a couple of more questions, and then probably it's time to close. A question has to do with let's say, the structure of your teams. So the question is, do you have geographically dispersed teams? And if so, how do you make sure that they share learning and then they actually learn what has happened?
Yeah, so historically, Netflix has been mostly most of the engineers are located here, or my location in Los Gatos, but that has been changing over time. So now, like our team is actually split between Los Gatos and Los Angeles right now, with I think one person is remote in like Indiana or something. So most of Netflix historically has been co-located locally for, I think, the express reason that its communication is easier that way. But we are a global company now, and people, some teams are distributed and some people work from home. And so we have to deal with, we do have to deal with some of the distributed stuff. I mean, we are very heavily dependent on Slack, for example, for doing communication. Like, so for example, during an incident itself, it's mostly handled through Slack. If people are here, sometimes there's like a situation room where we'll bring people into that room together and they can talk, and we can open up a conference bridge, but the communication is much richer for people inside the room, right? And they can write on the whiteboard and they can see it. And so it's, you know, we have tried historically to have people co-located, but we have to still deal with the remote, and we're dealing with it the way everybody else does with video conferences and Slack messaging and things like that.
Okay, so last very quick question. Do you have a public example of your investigation template? Something that you can share?
No, I don't. I would really love to be able to like create sort of a synthetic write-up that I could share. We haven't done it yet, but it's something that I would really at some point like to do, because you learn best from examples, and because there's too much sort of proprietary stuff, I can't share like a regular internal write-up, and it wouldn't make sense to most people anyways. And we also put people's names in there. So we don't have any, but it's something that we'd like to be able to do in some form at some point, so people can see it.
Yeah, I guess this would be greatly appreciated. So I think we are running out of time. So I would like to thank you, Lorin, again for this informative presentation and insightful answers to the many questions. And a special thanks to each of the listeners for taking the time to attend and participate today. So this talk was recorded and will be available online in a few days at learning.acm.org. You can find announcements on upcoming talks and other ACM initiatives on the same website, so learning.acm.org and also acm.org. So you will see that there is a quick survey, so please fill it out. We really welcome your suggestions for future topics and speakers, and you should see this form on the screen. So on behalf of ACM, on behalf of Lorin and myself, thank you again for joining us, and I hope you will join us again in the future. So thank you, and this closes the talk. Thank you.